Good morning, guys. Today, inshallah, we're going to continue chapter 5, section 3. We're still talking about the graduation of some physical properties of elements in the periodic table. So, last time we already studied three properties. We studied the graduation of atomic radii or the atomic radius, which represent the atomic size. And we know that as we move downward in a group, the atomic size increases because we're adding more sub-energy levels. And as we move across the period, the atomic size decreases or the radius decreases because the number of positive protons increase, which represent more attraction force to the outermost electrons. Then we pass to another property, which is the ionization energy. And we said ionization energy, the amount of energy needed to release electron or to make this atom lose electron. And then we said the ionization energy increases as we move down within the group because as the atomic size increases, the attraction force between the nucleus and the outermost electron decreases, so it's easier to be lost. Okay, so that means we don't need that much of activation energy. So like this, the ionization energy decreases as we move down in the group while we move across the period because the size of the atom decreases, which represents more attraction force between the nucleus and the outermost electrons. So we need more energy to, or we need more ionization energy. Then we call about electron affinity. We said that electron affinity that's happen when an atom, or the change in the energy when that atom gain an electron. And we said also within the moving within the group, okay, downward the electron affinity decreases, and as we move across the period, the electron affinity increases. Today, inshallah, we're going to talk about another, which is atomic radii. What mean, guys? Sorry, we are going to talk about a new one, which is ionic radii. So, what is ionic radii, guys? So here, as we said, ion, it's the atom that lost or gained an electron. So atom, once it loses electron, the number of positive protons will be more than negative electrons. So in this case, it will be a positive ion. While here, once the atom gain an electron, it will be a negative ion because the number of negative ions will be more than the negative will be more than the positive protons. So the negative ion is called anion, while the positive one we call it cation. So here we said that the formation of a cation, the formation of positive ion by the loss of one or more electrons always leads to decrease in the atomic radius. Why? Because simply when we lose electron, it may we lose some energy levels in case of metals. Okay, so like this. Okay, sodium, for example, Na11. So if we're just looking here with me, guys. So we said that, for example, okay. So Na11. So the electron configuration 1s 2, 2s 2, 2b6, 3s1. So when it loses this electron, that means we already this energy level, sub energy level is not found anymore. And like this, okay, the number of sub energy level decreases, which means the electron cloud becomes smaller. And like this, it's the radius of the ion always is smaller, or the radius of a cation always is smaller than its original atom. So the remaining electrons are drawn closer to the nucleus by its unbalanced positive charge. That means here, because now we have positive 11 while negative 10, which means representing more attraction force applied on the electrons. So like this, they're gonna be smaller. While formation of a negative ion, an ion, that's will cause, or almost it means that the size or the radius will increases. Why it leads to the increase? Because, for example, chlorine, Cl17, 1s2, 2s2, 2b6, 3s2, 3b, okay, 3b5, okay. So in this case, chlorine, once it gains an electron, okay, it gets an electron. So we are going to find that the 3p will completely filled by 6 electrons. That means all electrons now are doubled in their orbitals. That's to create a kind of repulsion force, okay, between, okay, the electrons. So they start to spread apart from each other, which causes it to expand. In the same time, here in this case, we're going to find we have positive 17 proton and negative 18 electron, which means represent less attraction force than in normal atom, which means, okay, the atom could expand or the radius would increase. So that's here the idea, okay, or that's how it represents, okay, the difference in the atomic radii. Regarding to this, okay, we could really compare between the size of an element, okay, and the size of an element atom and its ion. So that means what's it produce a positive ion, of course its size is smaller than okay, the normal atom, and what's produced negative ion, its size is larger than the normal atom. So here, like this, cationic and anionic radii decreases across a period. Both are going to pass across the period, and the electron cloud shrinks due to the increasing of the number of charge acting on the electrons in the same energy level. It means the number of protons actually will be higher, so they're going to attract the electrons more and more. So like this, they will be closer, okay, or they pass closer toward the nucleus, which means the radius will become shorter, which means the size decreases. The outer electrons in phosphatines and anions are in the higher energy levels as one reads down a group. Okay, so which means okay, it increases as we pass through the group. There is a gradual increase of ionic radii down a group. So here, like this, okay, we said that the ionic. Then we pass to another property, which is the valence electrons. What mean by valence electrons? Actually, valence electrons, they are electrons which could share in the chemical reaction. And actually, if we made an electrification for any element, we're gonna find only the electrons in the outermost energy level that are could share in the chemical reaction, because electrons in the previous energy levels, they are completely filled, they are stable, so they will not share in the chemical reaction. But electrons in the outermost energy level that always try to fill its energy level, so they may be lost, gained, or even shared to just complete their outermost most energy level to be like a noble gas, and that's the purpose of chemical reaction. So we find that chemical compounds form because electrons are lost, gained, or shared between atoms, and the electrons that interact in this manner, okay, they are the electrons in the highest energy level. And here we talk about the main energy level, not just the sub-energy level. So here the electrons available to be lost, gained, or shared in the formation of chemical reaction called these valence electrons. So valence electrons, they are electrons which are already found in the outermost energy level, and which they are able to be lost, gained, or even shared by another atom to form a stable compound. So valence electrons are often located in incompletely filled main energy level. So always they are incomplete because the only complete energy levels found in noble gases, and all other elements they try to be like noble gases, so they try to fill their outermost energy level. So for example, here the electron lost from the 3s sublevel of sodium to form sodium cation is a valence electron. So that means this electron represents the valence electron. So let's take an example just to clarify the idea here, guys. So we are gonna say, for example, here sodium, okay, Na11. So as we said, 1s2, 2s2, 2b6, 3s1. So here, once we said what is the outermost energy level, it's or the main energy level is the third energy level. Okay, so the third energy level just contain one electron only. So this one represents the valence electron which found in sodium. That means during the chemical reaction, the energy level 2 or the energy level 1 will not be shared in this chemical reaction because they already completely filled, but S still need to be completed, okay? Or they could share, they could just involve in the chemical reaction by this electron. So during chemical reaction, it's easier to lose this electron, and like this, okay, it will be completely filled, and in this case, it will be stable like neon gas. Another example here, chlorine 17, okay, as we said before, 1s2, 2s2, 2b6, 3s2, and 3b5. So in this case here, guys, once we look here, we find how that outermost energy level is energy level 3, and how many electrons they are found, they are 7. So the valence electron here are 7. Okay, so we have 7 electrons that could go through that chemical reaction. So in this case, this one, okay, just have 7 electrons in the outermost energy level. It could just get 1 electron here to make it completely filled, so it's easier to gain electron and form an ion. So like this, guys, we call these valence electrons. So valence electron is the number of electrons which found in the outermost energy level. Then, guys, here we pass to the new electronegativity. Okay, so what mean by electronegativity? Actually, electronegativity is the ability of the nucleus to attract the electrons of the bond. What does it mean here? Okay, so we said that valence electrons hold atoms together in chemical compounds. What does it mean? That means during formation of chemical, during sharing or in covalent bond, as electrons are shared between atoms, so these atoms are held together because of the shared electrons. The shared electron considered like the link or the bond or the connection between these two atoms. So like this, the electronegativity represents how the nucleus of the atom is able to attract the bonds, or able to attract electrons which are found in the bond. So like this, we find that, okay, the more protons found inside the nucleus, which is the more ability of the atom to attract the electrons of the bond. So guys, we're going to stop at this point, and we're going to continue next time. Thank you and goodbye.